one and all. I am here about Tech Talk presentation. My name is Steven from Aeronautical Engineering Department. My topic is voltage optimization. Let's enter into the topic. Voltage optimization is a term given to the systematic control reduction in the voltages received by an energy consumer to reduce energy use, power demand, and reactive power demand. While some voltages optimization devices have a fixed voltage adjustment, others electronically regulate the voltage automatically. Voltage optimization systems are typically installed in series with the mains electrical supply to a building, allowing all its electrical equipment to benefit from an optimized supply voltages supply. Voltage optimization is an electrical energy saving technique which is mainly installed in series with the mains electricity supply to provide a reduced supply voltage for the site's equipments. Typically, voltage optimization can improve power quality by balancing phase voltages and filtering harmonic and transits from the supply. Although not always, voltage optimizers are essentially transformers used to deliver power at a reduced voltage from the raw main supplies. The term voltage optimization is frequently misused as the term implies some form of selective voltage reduction which will improve the energy consumption within a building. Whereas generally these units consist of a transformer within a box offering so selectively and dropping voltage on all supplies, whether this would offer a commercial benefits or not. Some Vivo units have been installed on high frequency lighting circuits offering little or no commercial benefits. Therefore, one must be careful when the term is used. Most Vivo units are installed in commercial premises in between the raw mains, transformer, and main low voltage distribution board. However, this provides for no selectivity and in electrical engineering terms in considering a poor solution. A full study should be undertaken by the facilities manager and Vivo company to select which supplies could benefit the owner by reducing the voltage and which supplies would give no commercial benefits. Next, United Kingdom declared low voltage electricity supply in the United Kingdom. As per the Electrical Safety, Quality and Continuity Regulations 2002 is now 230 watts with a tolerance of plus 10% to minus 6%. This means that supply voltage can theoretically be anywhere between 216 voltages and 253 voltage depending on local conditions. However, the average voltage supplied from the national grid in mainland UK is 242 voltage compared to the typical European voltage of 218 to 222 voltage. And next, the average supply voltage in Northern Ireland is around 239 voltage and 235 voltage in the Republic of Ireland. Older electrical equipments manufactured for the UK was rated at 240 voltage and older equipments manufactured for continental Europe was rated at 220 voltage. It is a worldwide main voltages. New equipment should be designed for 230 voltage. VA mixture of equipment is likely to be found in older premises. All equipment places on the market within the EU since voltage harmonization in 1995 should operate satisfactorily at voltages within the range 230 voltage plus by minus 10%. Equipment rated at 220 voltage should operate satisfactorily down to 200 voltage by efficiently bringing supply voltages to the lower end of the statutory voltage range. Voltage optimization technology could yield average energy savings of around 13%. The higher the voltage, the higher the power consumption. In the case of a few resistance load, a reduction in voltage does not affect the energy used by the domestic appliances which use resistive loads except in devices such as kettles and toasters, which will take longer to do their job due to atmospheric losses. The main commercial benefits which installing Vivo units is on inductive loads like motors which run pumps, fans and the like. It is nothing but situation needed in the home. The potential energy saving can be up to 12% on electricity bills. A Vivo device will lower the voltage to the most efficient level to maximize the savings on electricity consumption. So you may notice certain things taking a little longer, such as a kettle may take a little longer to boil. It is also a common misconception that fridges and freezers does not provide savings through voltage optimization because they are fitted with a thermostat. Fridges and freezers operates completely different from resistive heating devices. With the resistive heating devices is driven from a higher voltage. The result is heat, which is helpful to us in its intended purpose, heating. If a fridge or freezer is driven from a higher voltage, the result is also heat. However, this is not helpful in its intended purpose, cooling. The compressor motor power output is reduced slightly by voltage optimization, so the fridge or freezer thermostat will help the motors on a little longer. However, overall the effect is for the motor to run slightly longer at much lower cases. Test as Manchester University showed a 10 degrees Celsius reduction in motor temperature under voltage optimization due to the reduced losses in the motor. And there is a most common power quality problem, over voltage. Over voltage is nothing but it refers to voltage higher than the voltage at which equipment is designed to operate most effectively. It can cause a reduction in equipment lifetime and increases in energy consumed with no improvement in performance. A contemporary on the wiring regulations BS 7671 makes the following statements in relation to over voltage. A 230 voltage rated lamp used at 240 will achieve only 55% of its rated life, referring to incandescent lamps, and a 230 voltage linear appliance used on a 240 voltage supply will take 4.3% more current and will consume almost 9% more energy. Various technologies can be used to avoid over voltage, but it almost be done so effectively so that energy saving resulting from using the current voltage are so offset by energy wasted within the device used to do so. Reliability is also important, and there are potential problems inherent in running fuel incoming power through electromechanical devices such as servo control variable auto transformers. And under voltage refers to voltage lower than the voltage at which equipment is designed to operate most effectively. If the design of the Vivo does not take into consideration voltage drop over distance to remote power users, then this may lead to premature equipment failures to startups, and increased temperature in the case of motor winding and loss of services. And next, harmonics. Harmonics is nothing but our currents and voltage waveforms at multiple at the fundamental frequencies of the 50 Hz or 60 Hz main supply. Harmonics are caused by nonlinear loads, which include power supplies for computer equipment and variable speed drives and discharge lighting. Triplane harmonics, odd multiple of the third harmonic, results when phase voltages are not balanced in a three-phase power systems and add in the neutral, causing wasteful currents to flow. It is nothing but voltages are not balancing in three phases because it is called as triplane harmonic. The most possible effect is the level of harmonic known as total harmonic distortion becomes too high, include damage to sensitive electronic equipments and reduction in the efficiency of the HV transformer. The efficiency of electrical loads can be improved by attenuating harmonics at the supply or by preventing their generations. Some voltage optimization devices also mitigate harmonics, reducing losses associated with harmonic content on the electrical system. Next, transients are a large, very brief and potentially destructive increases in voltage. These causes include lightning strikes, switching of large electrical loads such as motors, transformers, and electrical drives, and by switching between power generation sources to balance supply and demand. Although they typically only last thousands or millions of a second, transits can damage electronic systems, causing data loss, regarding equipment's components, and shortening equipment life. Some voltage optimization devices include transients, potential, and protection also. Phase voltage imbalance. Industrial and commercial sites are supplied with three phase electricity. Imbalance between the phase causes problems such as heating in motors and existing wiring, leading to wasteful energy consumption. Some voltage optimization devices are able to improve balance on the building's electrical supply, reducing losses and improving the longevity of three-phase induction motors. It is improved to balance and building's electrical supply and also losses the reducing and improvement longevity of three-phase induction motors and it heating in motors and existing wirings leading to wasteful energy consumption. These are supplied with three-phase electricity. And next we go into the effects on electrical loads. A common misconception as far as voltage optimization is concerned is to assume that a reduction in voltage will result in an increase in current and therefore constant power. Whilst this is true for certain fixed power loads, most sites have a diversity of loads that will benefit to a greater or lesser extent with energy savings aggregating across a site as a whole. The benefit to typical equipment at three phase sites is discussed below. Three phase motors. Three phase induction motors are probably the most common type of three phase load and are used in a variety of equipment including refrigerations, pumps, air conditioning, conveyor drives, as well as their more obvious applications. The derating effects of over voltage and three phase imbalance of AC motors are well known to us and exec- excessive over voltage results in saturation of the iron core, wasting energy through eddy currents and increased hysteresis losses. Drawing excessive current results in excess heat output due to copper losses. The additional stretch of overload on motors will decrease motor lifetime, avoiding over voltage iron of to cause saturation does not reduce efficiency, so substantial energy savings can be made through reducing iron. However, motor designs for the nominal voltage, example 400 voltages, should be able to cope with normal variations in voltage within the supply limits plus or minus 10% without saturation. So, this is unlikely to be a significant problem. Reducing voltage to an induction motor will slightly affect the motor speed as slip will increase, but speed is mainly a function of the supply frequency and the number of poles. Motor efficiency is optimum at reasonable load, typically 75%, and at the design voltage and will fall off slightly with small variations. Either side of this voltage, larger variations affect efficiency more. It is falls from slightly with the small variations from voltage. Motor efficiency is optimum reasonable load at 75% and design voltage. Larger variations affects efficiency more. Very lightly loaded motors less than 25% and small motors benefit most from reducing voltage. For the case of motors driven by variable speed drives, when the input voltage is reduced, there will be a proportionate reduction of the output voltage from the VSD and the motor will draw less currents and eventually consume less power. However, if the motor is running on high load greater than 80%, less than 80%, the reduction in voltage will result in reduced torque and motor will end up drawing more current and power. Lighting. When lighting loads are in use for a high propagation of the time, energy savings and lighting equipments are extremely valuable. When voltage is reduced, incandescent lighting will see a large decrease in power drawn, a large decrease in light output, and an increase in lifetime as a previous extract from the electrician's guide illustrate. Since the decrease in light output will exceed the decrease in power drawn, the energy efficiency luminous efficiency of the lightning will drop. It saves the energy on lightning equipments and extremely it is very valuable for high propagation to the time and it decreases in power drawn. A large decreases in light output increase in lifetime and it is extracts electrical guideline illustrates and light outputs will exceed the decreases in power drawn. However, other types of lightning can also benefit from improved power quality, including systems with resistive or reactive ballast. Fluorescence and discharge lighting is more efficient than incandescent lighting. Fluorescent lighting with conventional magnetic ballasts will see a reduced power consumption but also a reduced lumen output from the lamp. Fluorescent lamps on modern electronic ballasts will use approximately the same power and will the same light. Heating heaters will consume less power but give less heat. Thermostatically controlled space or water heaters will consume less power while running but will have to run for longer in each hour to produce the required output, resulting in no saving. Switched mode power supplies. Switched mode power supplies will use the same power as before but will draw a slightly greater than current to achieve this with slightly increased cable losses and slight risk of the increased current tripping MCBs. MCC is nothing but manufacture current breaking. Energy savings. The energy savings achieved by voltage optimization are an aggregation of the improved efficiency of all equipment across a site in responses to the improvements in the power quality problems outlined above. It possible techniques for saving in energy consumption in certain circumstances. And thank you for giving this opportunity.